Hey everyone, Rob here from Rising Edge Industries. This is going to be a very brief video of the configuration tool. This allows customers to command and control the data recorder. And because there are so many features and details, I'm going to skip quite a few of them in this video because I just want to provide a very high level explanation of some of the most important functionalities and also just allow people to see what the interface looks like and how some of it works. And so we'll start with our data recorder from the previous video. We actually have a second one plugged in to this workstation that we'll use at the end of the video to show off the last feature. This is all the same top view. This is a pack of playing cards just for rough mechanical physical comparison in size. This is a side view of another data recorder. And so we'll plug in the USB cable, it automatically starts charging, and then we'll pull the power enable jumper, let the device power up. It's now up and running. You see the blinking LED. One thing to note is pulling the jumper like that could be a very good analogy to an umbilical disconnect scenario. So if this does need to be embedded in a closed system for any kind of flight and put in low power mode, you could use the umbilical disconnect just like we did with the jumper to power up, and the unit can auto trigger itself as well, so it can run completely autonomously upon umbilical disconnect. So now we'll launch our software application. This is a graphical user interface. Use the command and control the data recorders. We've got two plugged into the system, serial number 19 and 20. We want to first connect to serial number 20, which is shown in the webcam image here, the top view recorder. So to connect, all you do is press the open USB button. There's no installation, and the device is automatically recognized with every operating system. The software will go find it based on serial number. These are basic command buttons. Down here is a set of channel gain controls and some controls for the analog front end. This is the checkbox that allows the device to auto trigger itself upon the next power cycle. This is what I mentioned in the beginning. It's very handy for being in closed systems where the customer doesn't have access. There are bootload capabilities, downloading a data file as simple as clicking this button. In most cases, the data recorder will remember its configuration parameters and runtime duration, and it will provide the correct amount of data to software on its own. Bootloading capabilities allow the device to be flashed and updated by the customer at the customer site. So if any bugs do arise, we can fix those, release an image, and get all of the products updated and fixed. The refresh USB button refreshes the list of connected active data recorders plugged into the workstation. Set configuration sets the current settings here as configuration parameters, as well as some configuration parameters in the menu we'll go through very briefly. Some of the main core controls are sample rate, 500,000 samples per second to 1 sample per second. This is split across channels, so you can pick 1, 2, 3, or 4. Apply the full bandwidth of data acquisition to that channel. You can do 2 channels. That divides 500K between the 2 channels at a max speed of 250K per channel. 4 channels, software automatically relist the data rates. The gains are 100 volts per volt. They're individually set for each channel. These are also applied directly to the analog front end. They are not done in the digital domain. These are done in the analog domain, which means for gain and offset being done in the analog domain, the maximum amount of signal content is presented to the input of the analog to digital converter. There are multiple modes, one-shot mode. These are the discrete trigger edges, rising edge or falling edge. There's a threshold setting for burst mode, allowing the device to use a pre-trigger circular non-volatile buffer to loop through until a threshold violation event greater than this value is seen on a user-defined channel. The device will then transition to post-trigger memory. This gives the customer a snapshot before, during, and after the event. Runtime is set here in seconds or milliseconds. So those are some of the basic interface configuration and commands. Start sampling is similar to a trigger. It commands the recorder to start sampling in any mode. Set configuration, get configuration. The battery gauge here is shown. It's updated continuously. The blinking percent symbol shows that the data recorder is running and communicating correctly to the software application. It also updates this battery capacity. So here we can see the device is at 27%, it's charging, and in the bottom right corner you can see there's an LED indication too, this amber LED here. Some of the more exciting features: the power system has its own firmware and commands and some telemetry information. For example, version 0.3 is our current latest version, and get temperature 26.5 degrees C. Those are handy. Software version and data recorder firmware version 1.2.16. One of the big things that stands out with this data recorder, though, that's extremely nice is the offset control. The DC offset control for these products, we have a visual display here with a few samples per second to give the customer a visual display of what's happening on that channel. This is generally used for calibration, so sensor biasing will move your DC offset, especially with a bridge, because it's usually around half of your biasing voltage. So this allows customers to visually walk the DC offset up and down from a software interface. And so, for example, if we want to set the offset to an ADC code of 2000, we just plug in 2000, make sure the radio button samples is checked, and our offset target hits 2000. There's some telemetry status information over here. Each channel has its own tab. They're all set individually. All of the parameters for gain and offset, these are all set individually in the analog front end. So we can see here. The y-axis is ADC codes. The x-axis is number of samples flowing through the software display. And there's also an option to allow the data recorder to auto-tune its channel to a floating point voltage target. So this will be shown below. You can see a little bit of undershoot with the control algorithm, and then it settles in at right at 1 volt. If we go to 6.5, it'll be right around 2048. So you have an option to do voltage configuration. It auto-tunes itself. The time does increase as gain increases. The gain does add complexity to the offset tuning under the hood, but most of the time sample settings are more than enough, and these are direct sets, so they're very simple. So this allows customers to walk this up and down, and I'll touch on one of the main benefits here, probably the largest benefit of this functionality, besides it being so much easier to use and not involving external test equipment. One of the main benefits is that customers that have a lot more overshoot than undershoot can now walk this down to lower and lower values and can tune this DC offset so that they get the most information out of their waveform. And that's extremely helpful when you have a sensor. You want to be able to use as much of the signal it outputs as possible. And if you're stuck at half of your bias voltage and your overshoot's larger than your undershoot, you're limited by half of VCC until you have a clipping problem. So being able to walk this down means customers can now get much more out of each data channel, And each data channel can also be individually configured for a different sensor. So a different sensor could be loaded on every single channel, and each of the 4 channels can be individually tuned with gain, DC offset, to get the most out of your sensor output, most out of your waveform. This is all in the continuous analog domain as well, so this is a control into the analog front end. One of the other features we'll end with here that is really cool, and I think we'll find a place in a lot of test labs, especially but also at test ranges, will most likely be this real-time plotting. We have a real-time plotting interface in the device now, and so we'll pick our other data recorder, serial number 19, and open this. And the last item I'll go over quickly here in this video is the R plotting. So this is real-time plotting capability here. So this data recorder is actually plugged into 3 sensors and 1 signal generator. And we'll just use a signal generator as an example. It's on channel 3, so we have channel 1 at the bottom, channel 2, channel 3, and channel 4. So we'll just inject a sine wave into channel 3, but this is a 3.9K 3,900 sample per second per each channel heads-up display real-time here. So it gives the customer insight into what kind of signals are active on the channels in a low data rate setting. This also logs all the information to a CSV file that's time-stamped and has an incremental number attached to it. This increments every time the heads-up display is open, so all this data is saved and it's streamed into a standard non-proprietary CSV file with a time column and data columns. So for example, if this was connected to sensors in a test, and it would be nice to see that all the channels were up and running correctly, some test stimulus was also up and running correctly, the sensors were plugged in together. So we've just turned on a sine wave output from our signal generator at just a couple hertz, and we can see in real time this is oscillating by. This is a fully differential signal, so it's 2 sine waves of 500 millivolts, 180 degrees out of phase. So if we turn one off, we can see we get half the magnitude, and we turn it back on, we get the full magnitude from the differential signal. Once we align the phase, there we go. Now they're out of phase. So this gives you a nice real-time display. It's also logged. Every sample is logged in a CSV the entire time. If this is open again, the CSV doesn't get erased. It's just incremented. The file name is incremented, and a new CSV is created. The second tab is also handy. It's an overlay of all of the data plots on top of one another. It's the same real-time plot, and there are some controls down here that let you turn them on and off. But for low bandwidth needs and general lab use, some basic sensor checkout, this is extremely handy. It's very helpful. Gives you accurate insight into what's happening instant by instant on the channels. And there are a few basic controls that allow customers also to zoom in here to an individual channel. So if this was a higher frequency signal, we could zoom in and see a little more of it here. So now we'll close this. Closing that window closes and flushes the data out of the received threads into the CSV. And from here, we can now open this up, and we can see that we have all of our data stored. Time column, data column, channel 1, 2, 3, and channel 4. So that's it for this video. It's actually gone on longer than I had hoped. So this is a brief overview for the high level discussion of the product line and the supporting software. The next video series will go into a lot of detail in what kind of control you have, performance, capabilities of the software interface, triggering, and we'll do quite a few test implementations here in the lab. So stay tuned and come back. If you have any questions, you can contact us at support@RisingEdgeIndustries.com. Feel free to visit our website, and we'll see you in the next video.